Greetings, everybody. So, thank you for tuning in. Thank you for tuning in and welcome back. So, what we're going to do now is we're going to get into a new topic, okay, for term 3. So, we're going to start a new topic today. I want to give you a what? An introduction to a new topic. We're going to start with vectors and scalars. Vectors and scalars. So, these are physical quantities that we are. So these are physical quantities, okay? Okay. Let us begin with a what? A short explanation here. We come into contact with many physical quantities. Okay. Many physical quantities. Physical quantities. So we come into contact with many physical quantities in the natural world. In the natural world, on a daily basis. On a daily basis. So there are many physical quantities in nature. There are many physical quantities in nature. And we can divide them up into two broad groups. Called vectors and scalars. And scalars. So this is a short explanation of what these things are. Okay. So we should familiarize ourselves with what scalars and vectors are and how are they different, isn't it, from each other. So they are different from each other, and that's what we should know. So the first basic thing to know is that they are physical quantities. Well, they are not the same, but they are both physical quantities that occur in nature. Okay. So now I want to get into what are the differences between what scalars and vectors. So I'll begin with scalars. Okay. I'll begin by explaining what scalars are. So this is it. Let's begin with scalars. So scalars are physical quantities. Physical quantities which have only a number value. Or size. Okay? So we can say size or we can say magnitude. Magnitude is the same thing as size, okay? So it's a synonym. So a scalar tells us, it tells you how much, okay? So a scalar is the size or the magnitude of something. So it answers the question, how much? So it tells you, a scalar tells you how much of something there is. Okay, so this is a nice explanation, you see. Scalars are physical quantities which have only a number value. So they have only a number value or size. So you can say size or you can say magnitude. A scalar tells you how much of something there is. See, so a more formal definition here. So This is a more what? Formal definition. A more formal and summarized definition. You can write it like this. A scalar, because you will be required to define. Yes, okay. A scalar is a physical quantity. It's a physical quantity. It's a physical quantity that has only only um, that has only magnitude. It has only a magnitude. Magnitude or size. So these two words will be used interchangeably, magnitude and size, because they mean the same thing. Okay. So the key words here, okay, is what? Magnitude. Only magnitude, because you should remember that, because this is what makes it different from a vector quantity. Okay. It has only a magnitude. So you don't have to use both words. You can use one, okay? You can use magnitude or you can use size. So a scalar is a physical quantity that has only a magnitude or size. See? So, okay, that is a what? A more formal definition. If you're asked to define what a scalar is, okay, and that's what they say. It's a nice explanation here. Scalars are physical quantities which have only a number value or size or magnitude. A scalar tells you how much. So it answers the question of how much of something there is. Okay. Now let us look at what um, examples of examples of scalar quantities. So examples of scalar quantities include the following. Okay. So I want to show you what examples of scalar quantities here. So these are physical quantities that have only magnitude. They have size. So they don't have size and direction. So let's get into it. So an example. So for example, if you have electric charge, okay, electric charge so electric charge has only a value. Okay, electric charge has only a value, no direction. So it's an example of a scalar quantity. So, and then another example would be volume. Okay, volume also has only a value, has only a value, no direction. And then another example would be mass. This is a very popular. So mass has only a value, no direction. So these are examples, you see. These are examples of physical quantities that have only a magnitude. So they have only a number value with no specific direction. See? So um, let us now get into vectors. Okay, let's get into vectors. So let me explain what vectors are. So let's get into vectors. Okay. So we can see what the difference is. Okay. So what makes vectors different from scalars? Okay. What makes vectors different from scalars is that they are physical quantities. That they are physical quantities is that they are physical quantities which have a size or magnitude. So you can say size or you can say magnitude. And direction. And direction. So a vector, so they have magnitude and direction. So okay, so now a vector has two things, because a scalar quantity has only one thing, which is magnitude. So, but then a vector, so a vector tells you how much so the keyword here tells you how much of something there is, so it tells you how much of something there is and which direction it is in. So it tells you, so it answers two questions, okay? It answers the question of how much of something there is and in which direction that something is, okay? So from this explanation, we can come up with a what? A more formal definition of a vector. So we're going to say so a vector is a physical quantity. Is a physical quantity is a physical quantity that has both so it has both magnitude size and direction. So it has, and this is what makes it different, isn't it, from a scalar quantity. A scalar quantity has only magnitude. It has only the size, while the vector quantity has both the size and the direction. See? So what are the examples? What are the examples of? So let us look at what? Examples of vector quantities. Include the following. So I'll give you a few here. So a force, okay, force. What? So it has value and direction, isn't it? So it has a number value, it has a value and direction. it has a value and direction. You push or pull. You push or pull. Or pull something you push or pull something with some strength. With some strength. Yeah. So the strength in this case will represent magnitude or size, isn't it? The strength of the force that you are applying will be the magnitude or size. Magnitude or size. Magnitude or size. So this is in a particular direction. So it is in a particular direction. So when you push or pull something, it is in a particular direction. So you could be pushing it to the left or to the right. So it has direction as well as the what? The magnitude. Okay. So force, it has what? It has a value. It has value and direction. So you push or pull something with some strength, with some kind of a strength, which is the size of that of the force. Okay. And in a particular direction, you could be pushing it to the left or to the right, or you could be pushing it up or down or pulling it up or down. So force has what? Direction. See, this is what we mean. Okay. So another example, you can use what? Um, Another example of it. So it could be, we could say velocity. So velocity of an object. So it has a value. It has a value and direction. So a further explanation here, what? An object moves. So because what velocity involves movement, isn't it? An object moves so an object moves so an object moves with a certain speed with a certain speed in a particular direction. Okay. So it could be moving to the left or to the right again, or it could be moving north or south. So the velocity has speed and it also has direction. So it makes it a what? A vector quantity. Um, Another example is weight, okay, which is a special kind of a force, okay, that is tied to gravity. It has what? So it has a value and direction. It has a value and direction. Okay, so your weight is proportional to your mass. So your mass, which is a scalar quantity, okay, to your mass. So your mass in this case will represent the magnitude, okay, because a scalar quantity has only magnitude. And it's always is always is always in the direction towards the center of the earth. The center of the earth. So this is the direction that it always takes, isn't it? It has one direction only. So you could say towards the center of the earth, or you could just say downwards. Okay. This is it's a more scientific explanation here. But you could also say downwards. It wouldn't be wrong. Okay. Um, okay. Let's leave it here for lesson one, okay? Let's leave it here for lesson one. You can, but you can take down what you think is important. Okay? Take down what you think is important, okay? But then this gives you an overview, okay, of the difference between the two physical quantities, the vector and the scalar quantity. Okay. So you should remember that what? The scalar has only magnitude, but the vector has both. It has both magnitude and direction. Or you can say it has both size and direction. So that's what makes it different from a scalar. A scalar has only a magnitude, or you can say a size. So it's a physical quantity that has only a magnitude. And then when you go to a vector is a physical quantity that has both magnitude and direction. So it has both of the things. And then I also gave you examples here of what? Of vectors. And I also gave you examples of what? Scalar quantities here. Okay? Yes. So let's leave it here for lesson 1, okay? The introduction. We will carry on in lesson 2, okay? With another key concepts on this topic, okay? So on vectors and scalars. So lesson 2, we're going to get into other very important concepts that you need to understand, okay? So I hope you tune in for lesson 2, okay? Bye-bye for now and stay focused. Stay focused and take care. Bye-bye for now.